Section 8 of the National Geographic Magazine, Volume 5. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by April Walters. The Improvement of Geographical Teaching by Professor William Morris Davis. Presented before the Society, February 3, 1893. The improvements needed in teaching geography in our schools involve a fuller investigation of the facts of the subject, a better knowledge of these facts by teachers, and a more skillful use of them in the processes of teaching. As a society, we are less concerned with the last two necessities than with the first, but I may briefly state my belief that skillful teaching goes along closely with fullness of knowledge. The third need will therefore be largely cared for when the second is supplied, but fullness of knowledge cannot be expected of a teacher while her understanding of the geographical features of the world and of our own country and of the home state in particular is gained only from the impoverished statements of the ordinary textbooks, and while original sources in which she may seek additional information are generally so few, so inaccessible, and so far below the standards of modern geographical research. It might truly be said that even if better sources of information were within reach, little use could be made of them. For we must recognize the great difficulties under which the teachers in our public schools labor, the variety of subjects that they have to teach, the overlarge number of scholars in their classes, the restrictions that tend to smother their individuality, the fatigue following many tiresome duties, the smallness of salary by which freedom of action toward large opportunities is hampered. Would that some means of overcoming these difficulties might be devised! But at present it does not seem so practical to turn our action as a society in this direction as to look to remedying the fundamental need, the need of a fuller investigation of the facts. It may not be generally recognized by our members that there is still great need of exploration close at home. It is not only in the further corners of the world that discoveries are to be made. Nearly every state in our country must be much more carefully studied than it has yet been before its physical features will be made known to us. The geographical descriptions now available in print would be very gently characterized if only called old-fashioned. Where newer material has been published, it is generally fragmentary, brief, and imperfectly illustrated. The first elements of geographical study, the physical features of the earth, especially of its surface, still call for devoted investigation. It is not simply a description of the forms of the land that is wanted. It is a recognition of the forms as dependent on structure and sculpture, and a comparison of like and unlike forms in a systematic manner. This requires special study, precisely as petrography does, and the desired end will not be gained until the work is placed in the hands of men especially trained for it. Having found this study an absorbing interest for several years past, I shall try to make my meaning clearer by introducing specific illustrations from New England. Southern New England consists essentially of a gently inclined plateau, rising to 1,400 or 1,600 feet above sea level in the rolling uplands of western Massachusetts and southwestern New Hampshire, and thence descending gradually southward and eastward to sea level at the coast. Footnote: nearly all the districts thus referred to in the address were illustrated by lantern slides. This inclined plateau is nothing more than a slightly tilted lowland of denudation, the product of long-continued destructive action of the atmosphere, by which a once larger mass was worn down to a surface of moderate relief, close to the base level of its time. The southeastern extension of the old lowland was depressed beneath the sea at the same time that its interior portion was elevated to form our New England plateau. The present coastline therefore lies roughly midway on the surface of old New England. The continuity of the plateau-like uplands is interrupted in two ways. Isolated mountains rise above it, and branching valleys sink below it. Mount Monadnock is a typical example of the former, with its bold summit more than 1,000 feet above the surrounding plateau. When seen from a distance to the southwest, it rises in symmetrical triangular outline above the level skyline of its base. It is not a mountain of local construction, raised by upheaval above the mass of the plateau. It is simply an unconsumed remnant of the greater mass of unknown dimensions and form from which the old lowland was carved. When the lowland was uplifted, Monadnock and its fellows were raised with it. In my teaching, Monadnock has come to be recognized as an example of a distinct group of forms, and its name is used as having a generic value. A long paragraph of explanation is packed away when describing some other mountain as a monadnock of greater or less height. The valleys by which the plateau is dissected have all been excavated since the uplift of the old lowland. Where the plateau is high, the valleys are sunk deep below it. The Deerfield Valley in northwestern Massachusetts is a full 1,000 feet deep. Where the uplift was small near the coast, the valleys are shallow. Where the rocks are hard, as is generally the case, the valleys are narrow, like that of the Deerfield above named. Where the rocks are soft, the valleys are wider, illustrating the general principle that mature and old forms are more rapidly developed on soft than on hard rocks. The Berkshire Valley, excavated in limestone between crystalline rocks and schists, is 6 or more miles wide. The Connecticut Valley, excavated in weak sandstones, is even wider, forming a valley lowland 10 or 15 miles from side to side and broadly dividing the plateau into eastern and western portions. Occasional beds of hard rocks, chiefly ancient lava flows, occur in the sandstone belts and are much less eroded. They form ridges rising far above the lowland, and indeed still retain nearly the height of the adjacent plateaus. Mount Holyoke, opposite Northampton, is a type of these ridges. It holds essentially the same relation to the lowland that Monadnock holds to the plateau. Both are residual mountains of harder rocks, but the two manifestly belong to different generations of geographical development. It appears from this brief outline that our New England geography is of composite quality. The uplands with their residual mountains represent the closing stages of one generation or cycle of development. The valleys represent the more or less advanced beginning of another cycle. The distribution of our villages and our occupations, the lines of travel, and the movements of population may all be shown to depend largely on the topographic forms thus classified. By following some plan of treatment such as this, it becomes possible to make just comparisons between different regions. For example, a close correspondence may be found between our dissected New England plateau and the Hundröchtanes plateau, through which the Rhine has cut its famous gorge below Bingen. Footnote: excellent lantern slides of this picturesque region may be had from dealers, much better, in fact, than can be found for our scenery at home, although the latter is much more important for the schools. End footnote. Here we find an even upland, with occasional eminences rising above it, and with deep valleys sunk below it. The eminences on the plateau are there, as with us, residuals of a once much greater mass, rising moderately above a base-leveled surface. The valleys are the work of a later cycle of development, inaugurated when the old base-leveled surface was uplifted to its present altitude. In all this, southern New England and the plateau of the Middle Rhine are thoroughly homologous, but certain significant differences between the two regions should be noted. The plateau of the Middle Rhine is so extremely flat-topped that it must be conceived as having advanced further in its first cycle of denudation than New England. Indeed, it is the best illustration of a smoothly base-leveled area that I have found, and serves me as a type of such form. On the other hand, its valleys are much narrower than ours, hence its second cycle must be regarded as less advanced than ours. Both regions possess composite topography, including similar elements, but the stages in the two cycles of development represented in each case do not precisely agree. I cannot now delay to illustrate other elements of our New England topography, even in so brief a manner as the plateau, with its residual mountains and its initiated valleys, has been treated, but I may record my conviction, based on experience with scholars of different ages and with teachers in schools of various grades, that all our geographical features, when studied out in a manner similar to that outlined above, become luminous in comparison with the obscurity of the conventional accounts in our school books. The drowned valleys that form our bays, the drowned rivers that form our estuaries, at once gain a new meaning when thus explained, and it is not a little remarkable to see how little recognition there is in general teaching of the control exerted by depression of the land on the form of its coastline. Look at Narragansett Bay, the fjord of the Thames at Norwich, the Connecticut above Saybrook, of the Housatonic toward Birmingham, of the Hudson even up to Albany, all drowned like Peggotty's brothers at old Yarmouth. Yet what schoolboy ever hears our coastal rivers thus simply and rationally characterized? Look at the sprawling outline of Greece, and ask our classical scholars if they describe it as a rugged mountainous region standing up in the Mediterranean up to its knees, and yet how effective is the homely comparison. It is the same with the results of glacial action. The textbooks of geography are practically silent on this important topic, yet many features of glacial origin must be known in fact to every boy who has ever rambled through the woods on his half-holidays. Our gravel ridges and mounds and our sand plains may be reckoned as a characteristic of our home geography, as Lowell's Bigelow papers are of Yankee dialect. It is a pity that they are not duly mentioned in our schools and compared with the suggestive fund of fresh material brought by Russell from Alaska and so honorably associated with the name of our society. The comparison that may be drawn here is as fair as that instituted already between New England and the plateau in the Middle Rhine, but the two comparisons are of different kinds. The comparison of the two plateaus associate distant regions that are now alike. The comparison of New England and Alaska employs the present of the latter region to illustrate the past of the former, and this style of comparison is extremely suggestive in geographic study. For several years past, some of my more advanced students have chosen as subjects for their theses the physical geography of various states with which they were more or less familiar from residence or field observations, or with which they wished to become familiar. They have thus had occasion to search the literature of each state for accounts of its physical features, and the search has generally been without large reward. The practice has been useful, but the product has not been great. It is this want of material that convinces me that nothing less than the direct exploration of our home country, with the single object of investigating its topographical development, will secure the facts that are now needed in geographical teaching, and thus we return to the general question that was laid aside while southern New England was before us. It is, of course, impossible in the limits of this address to give a full statement of the scheme of systematic geography, the appreciation of which seems to me essential in the desired exploration and investigation, but there are two leading principles which I may outline, since without them no progress can be made. The first is that every landform passes through a comparatively systematic series of changes from its youth, when its form is defined chiefly by constructional processes, past its maturity, when the processes of sub-aerial sculpture have carved a great variety of moldings and channelings, toward its old age, in which the accomplishment of the full measure of denudation reduces the mass essentially to base level, however high it may have been originally. I have become accustomed to call this unmeasured time a geographical cycle. It may be long for a structure of hard rocks, or shorter for a structure of weak rocks, but in both the sequence of immature, mature, and senile forms is essential. The particular expression of these forms varies with the structure of the mass concerned, but for every structure there is an appropriate sequence of young, mature, and old features. It is therefore important to determine, in accordance with this fundamental principle, the stage in which any given area stands in its life's journey. The standard descriptions of many of our states gives no such account of their topographic forms, and the student or teacher who seeks it has little reward. The account is needed not only because the reader can gather from it a better understanding of the relations of a region to the rest of the world, but also because such an account enables him to appreciate much more closely and more easily the actual forms of the region itself. A second important principle is in a measure a corollary of the first. At any time during a geographical cycle, a land area may be disturbed by depression or elevation. A new relation is then established with the base level of drainage, and a new cycle of denudation is introduced. The forms developed by denudation in the first incomplete cycle then become, as it were, the constructional forms of the new cycle, and from those as a beginning the forces of denudation go on anew. This combination of the topographic features developed in the two cycles produces what I have called composite topography, and this is of extremely common occurrence. For an example, we may again refer to the dissected plateau of southern New England. The upland with its residual mountains is the product of an earlier cycle. The valleys are the work of a later cycle. The glacial features may be referred merely to a short-lived climactic episode later in the second cycle. So brief was the occupation of the country with ice compared to the time required for the excavation of the valleys in the uplifted plateau. Geographical descriptions and the appreciation of them are greatly advanced by a recognition of these principles. They are essentially simple conceptions, but the variety of their application is infinite. The work of more than 2 cycles may not infrequently be recognized. Thus, in Pennsylvania, the crest lines of the Appalachian ridges are remnants of an uplifted and almost consumed plateau of Cretaceous denudation, of which only the hardest parts now remain. The open valley lowlands between the ridges are the product of a tertiary excavation in the uplifted plateau. The narrow trends in which the rivers traverse the lowlands are of post-tertiary origin. Many points of view may be selected on the Susquehanna, where these 3 elements of the landscape stand out with much distinctness, and the pleasure of their contemplation is greatly increased by the recognition of their distinct condition of origin in successive geographical cycles or during successive uplifts of the land. What is the most effective way in which we can promote the advance of geographic investigation and secure accounts and illustrations of our home country in accordance with a systematic and scientific method? It has seemed to me that appeal might be profitably made for the cooperation of the directors of the various state geological surveys. I therefore propose to ask the directors of our various state geological surveys to devote annually a part of their funds to the study of the physical features of their domains in the light of modern geographical science, provided that the terms of their appropriation bills will allow them to cover this side of the geological field, and if not, I shall hope that special appropriations of moderate amount may be made for this particular purpose. Experts should be employed for this work, as they are now in paleontology and petrography. The results thus gained would appear in successive annual reports, brief at first, increasing in scope as opportunity offers, and setting forth the larger and smaller elements of the topography in such simple style and with such comparisons and illustrations as should be of immediate value to teachers in grammar schools and high schools. The state boards of education might secure special reprints of these geographical chapters at very moderate cost for distribution as state products to all public libraries and to all public schools of the higher grades, much in the same way as the energetic commissioners of the Topographic Survey of Rhode Island have secured the distribution of their state map free to all their public schools and libraries. The legislature would soon see the employment of these geographical chapters year after year by thousands of teachers, the appreciation that this hitherto undeveloped economic field might receive from those occupied with the advance of public education, and assured support would then be given to the work, even on a large scale. By some such practical steps, we may secure material advance in the quality of geographical instruction. During the past year, I have had many illustrations of the need of material geographical of the kind here referred to. Teachers in our public school are well aware that they have not now the fuller account of the facts that they would enjoy, and yet they know not where to turn to find what they need. Many teachers, principals, and superintendents with whom I have spoken admit at once that the books to which they now have access are quite insufficient to satisfy their wants, and they listen gladly to any feasible plan that will provide a more extended and more scientific description and explanation of the facts of geography near at home, with which they have to deal from their earliest to their latest teaching. Geologists or geographers who are already acquainted with our local geography from personal experience can perform a grateful service to the schools by preparing elementary accounts of the regions with which they are familiar, and such books as these should be greatly multiplied. But, so far as I have been able to learn, it is only the smaller part of our country that is now known well enough to those who can be prevailed on to write elementary books, and hence the importance of actual geographical exploration in order to supply our teachers with what they need. If some such plan as the one proposed above were put in operation, it might come to pass in a decade or two that the graduates of our common schools would not be so blinded as they now are to the facts of their home geography. Harvard University, Cambridge, Massachusetts. End of section 8.